Don't worry, I'll get that off the screen in a second here. But the electron, the proton, the neutron, they can make all these elements. So there's the helium. 2 protons, 2 neutrons, 2 electrons, you got a helium atom. Pretty cool, right? Now, what's really neat is that we've actually broken apart the neutron and the proton into smaller things. Do you guys know that? Like the proton and neutron are actually made up of particles called quarks, and they have really lame names like the up quark and the down quark. But 2 down and an up make a neutron, and 2 up and a down make a proton. And the electron, man, we're smashing that thing and it won't seem to break, okay? Now, here's the thing. You guys have mass, and these particles have mass. And these particles have really, really, really small masses. Like how small? Like all those numbers, okay? That's small. What would happen if, like the cake recipe, we start changing things? Like, what if we just took the down quark and increased it by a factor of 3? What happens to the universe? Here's what happens to the universe. You know chemistry? It's almost completely gone. Some of you guys are thinking, that's great, I don't like chemistry. The problem is you're made of chemistry, okay? So when it goes, you go. In fact, on this universe, all you have is hydrogen. That's it. Just hydrogen in the universe. No planets, stars, galaxies, none of it. What happens when we change the up quark mass by a factor of 6? Well, when we do that, remember chemistry again? It's totally gone. And you're literally left with nothing but neutrons floating around the universe. Similarly, with the electron, you increase that by a factor of 2.5. Just a little bit. What happens to the universe? You're back to a neutron-only universe. That is a cold, dark, lifeless universe. Is this starting to change the game a little bit? It's starting to sound like, man, maybe it was intended to be this way. Maybe there's intentional design. Now, Lee also mentioned gravity. Every 2 objects in the universe